Let's go ahead and take a look at a couple of sample functions. So let's first remember that this is our basic equation. Y is equal to A times e raised to the r power, all raised to the x power. So let's go ahead and identify our A and our R value for this. So our A value is the number out in front, and that is a 3. And our R value, well, that must be just a 1, because I don't see any other number here with x, so it must be the implied 1. However, R is a positive number, and positive means growth. So this time, instead of comparing the number in parentheses to greater than or less than 1, we are comparing the number in front of x in the exponent and saying positive or negative. And since this is positive, we're going to have a growth function. We want to go ahead and plot this graph, and we will use Desmos or a graphing calculator to graph. And either way, what we're going to want to do is look at the table of values and take note of those values to plot on our graph. So let's take a look. Here is a graph of 3e raised to the x power. Notice that my y-intercept is at 0, 3 because my intercept is always going to be at the a value. But let's grab a few more points. We can see that we are headed towards 0 pretty quickly. So in order to do that, I want to go to a table and get a table of values. So these are not going to be nice, pretty numbers because we are dealing with an irrational number to start with. Remember that e is a number that continues forever, approximately 2.718. So you're going to want to write down a few of these values or take a look at those as we fill in the notes, and then go back and plot a few points. So let's go ahead and see what that's going to look like in our notes. All right, so once you plot a few points, you'll be able to get your graph. Remember that our y-intercept was here at 3. At 1, we were a little over 8, and then we just keep plotting a couple more points and generally head towards 0. So this can just be a sketch. It doesn't have to be a perfect graph. Let's go ahead and take a look at our characteristics. My y-intercept is at 0, 3. Remember that the 3 comes from our a value, because when x is 0, e to the 0 power, just like anything else raised to the 0 power, is 1. So 1 times 3 is 3. I have that same asymptote that I've dealt with. Y is equal to 0. And I honestly can't do anything to change my domain here. It's going to be all real numbers. And my range is still y greater than 0 because we haven't transformed it to move that asymptote. Let's go ahead and look at number 6. Here we have y is equal to e raised to the negative 0.5 x power. So just like before, I have an a value that is just the implied 1 in front of e, so a is equal to 1. But this time my r value, the thing that's in front of the x exponent, is equal to negative 0.5. And remember that if r is a negative number, then that means it's going to be a decay function. I would like for you to pause the video and go jump over to Desmos and put this function in, grab a few points, and come back and plot your graph, and then let's talk about our characteristics. All right, so if you put this into Desmos, you should have seen that it is indeed a decay function. We are very rapidly dropping down, and then we flatten out as we head towards a y value of 0. However, you should have noticed that we never actually got to 0, so we still have an asymptote here of y is equal to 0. Our y-intercept is 0, our a value of 0, 1. Domain, still all real numbers. And range, because of our asymptote, is that y is greater than 0. So the key thing here when you're plotting, make sure that you get a point here at 0, 1, and then pick out a couple of points or so either side of that.